Okay, if you're seeing my screen, you should see the calculate the derivative of the function. And this is a chain rule question. Not sure if you recall that or work through this on your own.
Okay.
Chain rule. You can treat u, if you want, as x squared minus 5x minus 1. And then what that does is g of x, it really is u, but we'll just write it this way, is this. And this is what you're taking the derivative of. The derivative of this is minus 6u to the minus 7 power u prime. Okay, so you have to take a derivative of this thing here. So the u prime is 2x power rule minus 5. So it's just taking these two pieces and putting them back in here.
Okay.
So your derivative is minus 6 parentheses the original function, that's your u, x squared minus 5x minus 1 to the power of minus 7, okay, times u prime, 2x minus 5. And now it's a question of like, well, how do we present the answer? This should be accepted, but because it's a negative exponent, that's why it goes to the bottom. So if you're simplifying, you keep negative 6 and the 2x minus 5 up top, and then the x squared minus 5x minus 1 to the power of 7 on bottom. I wouldn't necessarily recommend doing this because you could easily just make the wrong sign on the exponent and it's all wrong. So but this should be correct here. This should be acceptable.
Okay.
If there's anything, if you want me to give you another problem like that, just let me know. Otherwise, I'll move on to 21.
Oh yeah, you can move on. I just forgot like what to do.
Okay. This one is very similar because it's a chain rule derivative. Okay, so your u here is the exponent, 2x squared minus 5x plus 8 over x. This is a chain rule problem again. The u is often the thing in parentheses under the root, the exponent, whatever. U prime, so we'll find u prime first. This is 4x minus 5, and then this one's maybe the one that could be unclear. This is really 8x to the minus 1 power. So it's minus 8x to the minus 2 power. So your original function here, your original function h of x, it's really now e to the u. So the derivative of that, just like in the previous problem, it's whatever it is, whatever the derivative of that is, but this time you always multiply by u prime. So we take this u right there, this u prime right there, and those come in. So we get e to the 2x squared minus 5x plus 8 over x. So basically the original function times the derivative of the exponent, the derivative of the exponent we just found. It's right here, 4x minus 5 minus 8x to the minus 2 power. Okay, if you wanted to clean this up a little bit, you could move this in front. So it would be 4x minus 5 minus 8 over x squared times e to the 2x squared minus 5x plus 8 over x. That would be totally okay.
Okay.
All right, 28 looks like it could be next. Yeah, 28. Interesting. This one didn't. Sometimes they don't come in because clickable pictures. Okay. Let me see that. All right. Hercules Films is deciding on the price of the video release of its film, whatever. Okay. What price gives the greatest profit? Okay. So profit is revenue minus cost. The revenue is price times quantity. Okay, so your revenue function, your revenue as a function of P is price, which is P, so it's almost always P, times quantity, which is, let me actually write it out here, it's times Q. P is P, and Q is the 300,000 minus 10,000 P. So that's your revenue function. And then we'll just simplify by distributing, so it's 300,000 P minus 10,000 P squared. Your cost function, that's the one you have to figure out. They tell you it costs $4 to make, so that's 4 times P.
Okay.
That doesn't seem right though. It should be 4Q. Let me check Chegg here on this.
Okay.
See what they say on this, because I could be going down the wrong roads. For revenue be maximized. We want profit to be maximized. Sorry, this first one is completely wrong. So looking at this over again. Can you, oh, you got the answer there. Let me look up one more of these and see if I can. Okay, I gotta do some quick graphing here to give you the right answer. So let me switch my screen so you can see what I'm doing, and then I'll try to explain in more detail
Okay.
when I do that. So the first thing I'm going to do here is I'm going to graph the revenue function. So instead of using R, I'm going to use Y. So it's X times 300,000 minus 10,000 X. Okay, and you can't see it at all. So I'm going to change the window here. We're going to go 0 to about 50, and then the Y is the big one. You just kind of go by zeros until you get what you want. So it shows that the maximum is occurring here at 15, which we know is wrong because the answer is 17. So now what I'm going to do is I'm going to subtract 4x. And notice that doesn't do anything because let me see if I can do it a different way. 300,000 minus. Okay. So each copy costs $4 to make. So I have an extra 0 in there. That's it. Okay. And there's our answer. All right. So there's your answer, 17. So I'll try to explain that now, going back to the other screen. Do a better job of that. Let me do that real quick. Okay. So the price is, or the cost over here. If you're seeing my screen, the cost is a function of P, but cost is 4 times the quantity that you make. Well, what quantity do you make? Well, that's the same Q up here. So that's 4 times the 300,000 minus 10,000 P. Okay. So the net result of this is it's 1,200,000 minus 40,000 P, and that's your cost function. So your profit is revenue minus cost. So the key here is to realize that it's 4 times Q. Q is given. The cost is $4. Q is there, and that will help clear this up if you see this problem again. So your revenue function is right here. It's 300,000 P minus 10,000 P squared minus the cost function, 1,200,000. Make sure you put it in parentheses, minus 40,000 P. So now when you distribute this in, you get minus 1,200,000 plus 40,000 P, okay? And then you can combine like terms, like 300,000 P combines with this one. That makes 340,000 P, but I'm gonna put the minus P, the minus 10,000 P squared first. So plus 340,000 P minus 1,200,000. Okay, so that's your profit function. To maximize profit, you have to find a derivative, P prime. So your derivative is minus 20,000, power rule, plus 340,000 P, and you set that equal to 0. Oops, I'm sorry, 340,000, not P. Set that equal to 0, and then you solve for P. So you're going to move this 20,000 to the other side. 340,000 equals 20,000 P. Divide both sides by 20,000. And that's where P equals 17 comes from. Is there any follow-up to that you would like?
No, that makes sense.
Okay. As you can see, graphing it is way faster, but I know you have to show your work, so we'll continue to go down that road and do that. Okay. Looks like 30 could be next.
Okay.
30 is next. Snipping that in now. Okay. So the seems like we kind of did this the other night, but maybe it was just a similar problem. First one's asking about average cost. So average cost is C bar of X.
Oh wait, we did do this.
Yes.
Okay, we can skip it.
Okay.
Sorry, I must have just accidentally skipped.
No problem. I'll find the next one here to do. Looking like 52 maybe. Yeah, it looks like 52 is the next one here.
Okay.
All right, the rate of change, they give you some function here, okay. Use technology. So when it says use technology, that means you're going right to your calculator. And what you're doing here is you're going to use your math 9 to do this integral. And the integral, you're going to do math 9, and it's going to be the integral from 9 to 13. And you got to grab this function up here. So let me just snip that. Actually, that'll be probably the best way to do it. You're going to put, see if I can just overlay it. I didn't like that. Okay, so it doesn't want to let me do that. So you're gonna do math 9, and you're gonna integrate from 9 to 13, but instead of t becomes x dx. So you're just gonna throw that in your calculator. So that number, let's make sure you can get that number.
Um, 15.569.
All right, I am a little bit behind you in terms of entering it, so I'll be from 9 to 13. Yeah, I get that. It's just round to the nearest whole number, so we'll say 16. So that should be correct there, 16. And like WebAssign, a lot of the answers propagate to the next position. So this is also 16.
Okay.
Okay. During the, now this is 13 minus 9. I think it's the 4-year period. It might though be 5. I don't know if they make you add one from the start of the quarter in. So this is weird. The number of active users increased about 60 million during the blank period from the start of the first quarter in. Yeah, I don't first quarter. So it wants a year here. And I don't know what year to give it because you're starting at, okay, one is 2008. Oh, that's the first quarter. Sorry, I don't think this is right because the number of quarters is this is so weird.
The
Because
answer
it's
says during the 1-year period from the
yeah.
start of the first quarter in 2010.
So 13 minus 9 is 4 quarters, and you know that there are 4 quarters in 1 year. So that's how that number gets produced. And you said in 2010?
Yeah.
Okay. So how that gets produced is 2008 is where you start. So 1, 2, 3, and 4 are part of 2008. First quarter, second quarter, third quarter, fourth quarter. 5, 6, 7, and 8 are in 2009. First, second, third, fourth quarter. So 2010 is where quarter 9 starts. That's how they come up with that.
Okay. That's weird.
Yeah, I hope that that's not emphasized because it can be hard to repeat that. But the first part's not bad. You just put in your calculator and you go.
Yeah.
All right. 56 is the next one that I'm seeing. 56. Okay. All right. Producer surplus. Consumer surplus. Sorry. You got to do both. All right. So the first thing here is we have to remember, like normally in an econ class, you get a graph, you get this graph and get this graph, you find that point, and this up top here is your consumer surplus, and this is your producer surplus down here. It's kind of the same thing here. You have a function that's going down. So this P, it's 8 minus, it's doing something. And then there's this place where you hit it, and we need this value right there.
Okay.
I'm sorry, I made this wrong. So this is Q and this is P. Is that right? Okay, I guess that is right. Okay.
Yeah.
So P bar is here, that's 2. Okay, but you still need this Q value. So you don't have to do this, but this is just a graphical representation of what we're trying to do. First step here is to solve for Q. So you got to set these equal to each other. 8 minus 2Q to the 1/3 power equals 2. So you're going to subtract 2. So you get 6. Bring this over here. So you get 6 equals 2Q to the 1/3 power. Divide by 2. So you get 3 equals Q to the 1/3 power. And then you cube both sides and you get Q equals 27. And that's right there. That's that point. Obviously not drawn to scale.
Wait, did you subtracted 8?
You subtract 2 to get 6, and then you move this 2Q to the 1/3 over to the other side. You could also graph these like you could treat this as Y and this is X, and then this is Y, and you could just find the intersection of them. You get a graph like that and that, but you got to get those 2 points. So the reason you need those 2 points is because to find the consumer surplus, you have to integrate. You have to integrate from 0 to whatever this value is, because you always integrate along the X. And then they don't really emphasize this in your class, but it's top minus bottom. Your top is this curve. That curve is 8 minus 2Q to the 1/3. And your bottom is this line here, 2. And by this time in the course, they usually are okay with you just putting this into the calculator.
Wait, how did you get 2? Sorry.
Two is the is this bottom line. The
Oh,
top is this curve, and the bottom is this horizontal line.
so where is the 27? Like, why do you need the 27?
The 27 is the upper limit of integration. So the 27 goes
Oh,
there. The 2 goes there.
okay.
All right, we can do this by hand if you would like, no problem. But you
No.
definitely want to put in your calculator first, and maybe your instructor even said, hey, you can just throw them in your calculator.
I got 40.49.
All right, mine is about to compute. I got 40.5. Make sure this exponent's in parentheses.
Oh, okay.
40.5 for that. All right, so that was 56. 57 is the other side of this. Okay. 57 is producer surplus.
Is it like the same? Is it like the similar process?
Very similar. Yeah, it's just finding the bottom side. So the graph here is that producer surplus looks something like that. And then you hit it with this P bar. So this P bar equals 190 is here. This is the graph of this one here is P equals 110 plus Q. So you have to find this place right here, that Q first. So you set them equal. You set 190 equal to 110 plus Q, and Q equals 80. That's pretty straightforward. So when I know you probably got a formula for consumer surplus, but more generally, it's just top minus bottom. This is your top, and this is your bottom. It's this area in between. So it's the integral from 0 to 80. 80 comes from there. And then your top is 190 minus parentheses, whatever this function is, which is 110 plus Q dQ. Yeah. Yes, dQ.
How do you know which one's on top and which one's bottom?
Just visually, whichever one's higher.
Okay, so graph, put it in the calculator as like 110 plus X and then
Yes.
190.
Yes. That would be like your Y1 is 110 plus X. Your Y2 would equal
Okay.
190. Now, yeah, is this right? P's and Q's. They at some point sort of switch these, like one problem at the end, but I don't think that's the case here. So then you're just integrating this. This one I might reduce a little bit. This is 80 minus Q, and then integrate that.
$3,200.
I am about to get this calculated. So it's yeah, it's 3,200. $58.
Yeah.
Okay, I think we did this. This is like the last problem we did yesterday. I'll just remind you that you just put this into the calculator, but you have to
Oh,
change the limits.
yeah. Yeah.
The only thing I'll just remind you is somewhere it said 2009. So you do it from, you integrate from 9 to 14 of this thing,
Okay.
right here. You get your number, and then you get around, and there's 10 billion. So there's a few things that You gotta look up.
Okay, we can go to 59.
59. Okay, 59, 60. All right, 59, 60. Okay. All right. So you get in this class some areas of calculus that are I was surprised first time I saw this class, because this is a more advanced topic, but you can use some simple rules here. So the rule here for whether it converges, well, this problem always converges. So I mean, you can always just know that. Um, the issue here is this exponent has to be greater than 1 for it to converge. So your instructor might have sometimes said the integral from, well, actually it's any number to infinity 1 over x to the p. If p is greater than 1, it converges. Maybe you saw that. Maybe, but this number 1.5 is greater than 1, so it converges. Okay.
Yeah.
Now, there's a lot of stuff you can do here to actually get the answer. You could also go to you could also do a math 9 here and do this integral, but you can't use infinity, so you got to use some students use 10 to the 99, and you'll get really close, but you'll have to write it out as a fraction, whatever you get here, whatever you get as your answer, it might not be a perfect number. It might be 2.99999, and then you have to know to make it 3, kind of thing.
Okay.
But we're going to do it by hand as well. So but I just wanted you to be aware of that. So, so you're going to integrate from 1 to infinity, 8, and I'm just move the 8 outside 1, and I'm going to say x to the minus 1.5 power dx. So what you do is you use the same power rule that you've been using all second part of the semester. You add 1 minus 1.5 plus 1. 8 comes down as always, and this is done from 1 to infinity. So this becomes x to the minus 0.5 over minus 0.5 power. And then, I'm sorry, there's an 8 there as well. So you have to evaluate it at both limits. And just for simplicity, at infinity, it's going to be 0. But what some students do is they write 8 parentheses infinity to the minus 0.5 power over minus 0.5 minus, and then it becomes, you put in the lower limit in, 1 to the minus 0.5 power over minus 0.5. This right here on the left, this becomes 0. I don't even want to talk about why, but you just need to know that goes to 0.
Okay.
Plus,
even if it's negative?
Yeah, it doesn't matter. It goes to 0. Because you need to know how to do this problem on the screen, 59. And you're not in a math class where you need to understand why. You just need to know how to do this. Because the only thing that's going to change if you get this problem is the 8. It's the only thing that'll change when you see this. So this is 8 parentheses 0 plus 1 to any power is 1. 1 over negative 1/2 is this whole thing becomes 2. And then that becomes 2 there. So this equals 16. So more generally is whatever the red number is, your answer is your red number times 2. And it always converges.
Really? Should I just do that?
Well, it depends how much work you need to show. But yeah, if you get the same numbers, which you will, and then WebAssign shows you which numbers change.
Yeah.
The red ones. So yeah, that's the only thing that's different.
Okay.
All right, 60 is more involved. There's not a shortcut as there was in the previous one. Okay. There's a lot of things that, well, this one I believe converges. Yeah, it converges. Sorry. This one converges. And the integral here, we've talked about many times before. The integral of e to the k times x dx is e to the kx, and then 1 over k out in front. And if you're not sure about that, just take the derivative of this, which is itself e to the kx, but then you multiply by k, and that's where that cancels to become e to the kx. And
Okay.
k is a number. K is like minus 0.5. So the integral of this is itself e to the minus 0.5x 1 over minus 0.5. And then you evaluate from -2 to infinity.
It converges even though it's not greater than 1.
This is a different type of problem. So the previous one is 1 over x to the power.
Oh.
So maybe I should have thrown that there. So integral a to infinity e to the minus kx dx, it converges for, I think k has to be between 0 and 1. Not sure. I would have to check that a little more carefully, but this one will always converge on your exam.
Okay.
Okay, so this is the part where this is where you need to have a little bit of ability to do this. 1 over minus 0.5, and then you evaluate each of these endpoints. So it's e to the minus 0.5 times infinity. And by the way, this is not correct, but I'm just gonna write it in here because this is what most students do. Minus e to the minus 0.5 times -2. Okay, this part right here always goes to 1. Whatever number you get in your problem, like it might be minus 0.3 or minus 0.4, it always goes to 1, this part. And we don't want to talk about why, but that part always goes to 1.
Okay.
Minus, okay, this is negative 0.5 times -2, that's 1, minus e. So you get e to the 1. I don't know what it'll be in your problem. Times, this becomes -2, 1 over, like that. So if you wanted to distribute in, this becomes -2 plus 2e, and then most students write it as 2e minus 2 as your final answer for that.
Okay.
So you know how to do this problem. You know how to integrate. The only thing you don't really understand or have a good understanding of is this like infinity thing, but I'm telling you, it's always 1, and just deal with the other stuff. Hopefully you'll remember that on the exam. Same thing up here. I mean, I gave you the shortcut here, but this infinity has always become 0 for the 1 over x to the. Hopefully that helps to get you to get the answer correct. You'll never see this stuff again unless you want to take more math, advanced math. I think you have another business math class probably in your program, but.
How did you get the part where 1 minus e, like negative, or e to the -0.5 times -2? How does that equal e?
So it's really e to the 1, but it's not written.
Oh.
So that's just e. It's like writing x. You could write x to the 1, but most people just write x.
Okay.
Your answer will have an e in it for the second one. It just has to.
Okay.
I think that's all the questions you sent me.
Okay. Let me look for more.
Okay. I'm gonna just step away for like a minute, but I'll be right back, and I'll check for the email when it's ready. All right, I'm back. I'm just waiting for that email to come in.
Okay, I'm sending it right now. Okay, I just sent it.
All right, I see some more problems here. Great. Is there an order that you'd like to go through these in?
No, I kind of sent them backwards. It doesn't matter what order.
Let's look at 42. It's something we have not covered yet. We did do it in a previous lesson. 42 is an integration problem. It's a U substitution problem. So you can use U substitution when you're taking derivatives or integrals. Here, your U it's the exponent. It's the minus 3x plus 6. And the strategy I showed you is you immediately find du, or so du is minus 3, and then you have to put a dx, which is different than maybe some other problems here. You rewrite the integral, and you start substituting in. So you always substitute in for u, and you always substitute in for dx. And I forgot to do that here. You have to solve for dx. So dx is du over minus 3. So you're always going to substitute in for u and for dx. So in this case, it's integral 6.4 e to the u, and du is du over negative 3. So 6.4 and minus 3, they're just numbers. They're going to come outside the integral. So it's 6.4 over negative 3 integral e to the u du. And this is just a definition. Nothing sophisticated there. 6.4 over negative 3, and then e to the u integrates to e to the u plus c. Okay, and then you have to back substitute at this step. And your u is minus 3x plus 6. If you want, you can grab a calculator and try to simplify that. I don't know if it does simplify. You might just get another fraction. So I'll just write negative 6.4 over 3 e to the minus 3x plus 6 plus c. Don't forget that plus c when you're doing your exam on there. That's a critical thing for this class. Okay, so that's 42. 50s, we can do that. All right, calculate the total area of the region described. So total area means, and it says do not count the area below the x-axis negative. That means you want to do well, it doesn't matter in this problem, but if you're using your calculator, you'd use the absolute value. The graph of this problem from 0 to 25, it just looks like that. So all the area is positive. So I'm not sure why this stuff is in here, but all the area is positive in this one. So you're integrating from 0 to 25. Usually that's your a and that's your b. Square root of x dx. Okay, so this is something you can definitely do in your calculator. You can use your Math 9 on this and get a number. It's got to be a nice number though, because it's expecting something reasonable here. To do this by hand, should we do that?
I got 83.33.
Okay, so if you get 83.3 repeating, you have to convert that to a fraction. You have to know that that's 83 plus a third, and then you have to say, okay, well, I got to multiply that number by 3. So 3 times 83 plus 1 over 3. So it becomes 250 over 3 is your final answer.
Okay.
Do you want us to go through it by hand?
No, it's okay. Well,
Right. Let's just do it. I hear a little hesitation, so I'll just do it real quick. You're adding 1 to this, so it's x to the 1/2 plus 1 over 1/2 plus 1. Because you have limits of integration, you evaluate from 0 to 25. You're still going to use your calculator. That's why I keep emphasizing that. So it's 3/2 over 3/2 from 0 to 25. So you're going to put it's 25 to the power of 3/2 over 3/2, and this ends up equaling that 250 over 3 numbers. You still got to go to your calculator for that, probably. Okay. 50 is complete. 54 here.
Okay.
All right. This is a calculator problem. It says to use technology. It also says to round. When it says to round, you know, you're good with the calculator. It does say that the curves cross like one another. So like e to the x looks like this, and like I think what it's suggesting is that this is drawn really, really poorly. Sorry, that's really bad. So it's like that, and like the graph, there's just like it's like a sliver or something in there. Maybe I'm not sure exactly, but you're supposed to find that point of intersection, but you can integrate the absolute value of e to the x minus x. This is like top minus bottom again, from 1 to 2 dx.
Okay.
And you have to use technology here. So I mean, I kind of think that that's good enough here. You know, my experience is that a lot of the instructors just want to see that you did some work. They don't want to see all the work. If you use that absolute value, you'll get it. Because it takes into account where they cross on that. Let me see if I can get you a number.
3.17.
We'll get caught up to you here. Yep, 17. Now it says to go 3 decimal places, 0.8. So this would be 3.171 would be your final on that. Okay. 55. 55 looks like it's next. All right, let me snip that in. All right, so it's got two parts. It's got the like do the integral, and then it's got figure out the graph. So average of the function. So the average of the function is, this is a and this is b, these values. It's the integral, or 1 over b minus a, the integral a to b f of x dx. So for you, you're going to do 1 over 2 minus 0, that's b and a, integral 0 to 2 e minus x dx. So you're just going to take a half, and you're going to go to your calculator, do a math 9 again, like this, and 2 decimal places for your answer on that one. So I get, ooh, why did it do that? I get 0.43. Hopefully you get something similar.
Oh, I forgot to put the 1/2. Yeah, I got that.
All right, so now the next part of this is it's got a graph, and they all sort of have the same, well, the e to the minus x has this kind of shape to it, but we only care about from 1 to 2. Sorry, 0 to 2. Why did I put the 1 to 2? From 0 to 2. So the average value, this what you're looking for is this 0.43 value. 0.43. That's your line across here. So let me see if I can find the graph that best matches up with that. Looks like it's one of the earlier pictures. Yeah, okay, so it's the graph on the lower right. I'm gonna snip that in. So this line right here is at 0.43. And that's what you're looking for. So the red line is the average value.
Okay.
I think that takes care of those questions.
Okay, that's fine. We can stop there.
All right. I'll send you the notes and the screen recording out shortly. Thanks again for scheduling. I'll see you next time.
Thank you.
Bye now.